Problem number 1, we are given 8 numbers and told to calculate the mean and median first. So to calculate the mean, we use the formula the sum of all the variables over the number of variables. The sum of all the variables was 1,796,000 divided by 8. We get 224,500, and that's the mean. The median is the middle two numbers, which were 145,000 and 155,000, and you divide that value by 2. You add them together and divide by 2 to get the average of the two middle numbers, which was 147,500. A typical house price here would be represented by the median because of the 800,000 value, which is a high outlier, which affected the mean to make it not as normal. In problem 2, we are given numbers and asked to give the 5-number summary. The first number in the 5-number summary is the minimum, which is the lowest number. In the first quarter, which is halfway between the median and minimum. Median, which is the middle. Third quarter, which is halfway between median and max, and the max is 95. Then we're asked to find the IQR and identify the suspected outliers. First, to find the IQR, we subtract Q3. We do Q3 minus Q1, and that gives you the IQR. And then to find the suspected outliers, you take the third quartile, which is 80, and add IQR times 1.5 to 80, and that's for the high outliers, which is any value greater than 92. To find the lower outliers, you take Q1, which is 62, and subtract IQR times 1.5, which gives you any values that are less than 50 are low outliers. This is the box plot representing the graph. 55 is the minimum, 62 is the first quartile, 70 is the median, 80 is the third quartile, and 95 is the max. This graph is right skewed because the mean is greater than the median. Right. In problem 3, we are given that there is a shipping company with a normal mean of 12 pounds and a standard deviation of 2 pounds and packages shipped and their weights. We are given So we are given the mean of 12 pounds and the standard deviation of 2 pounds. We are asked what proportion of packages between 10 and 14 pounds. 10 and 14 pounds is going to be 1 standard deviation before and 1 standard deviation after. And we know that this section shaded is 68% of all values that are one standard deviation away from the mean and median in a standard curve. The second question asks what proportions weigh more than 16 pounds. 16 pounds is 2 standard deviations away, which would normally be 95% of the data. However, we need to include all of these values over here. So if you were 2 standard deviations away, there's going to be 5% of the data not included, broken up between this side and this side. Since we only have half of that, it is going to be 2.5%. Okay, for problem 4, we are assuming SAT math scores are normal with a mean of 500 and a standard deviation of 100 in the score. So first we're asked to find the top 10% of students and what that score will be. So first you find what the opposite of this part is. So 90%, because you want to find up to 90% of it. The z-score relating to that is 1.29. Then you plug it into the formula. 1.29 is your z-score, equals x, the value you're trying to find, minus the mean, which is 500, over the standard deviation, which is 100. First, you're going to multiply 100 to get 1.29, then add 500 to get 629. So any score that is 629 or higher is the top 10%. Next, you're asked to find the bottom 25%. So first thing you're going to do is find what z-score value relates to 25%. That z-score value is negative 0.67. So you're going to do the same thing and plug it into the formula. Negative 0.67 equals x, the value you're trying to find, minus mean over standard deviation. First, you're going to multiply standard deviation to the other side. Then you're going to add 500, and doing that gives you 433. So that means any value 433 and below is the bottom 25% of scores.